Hello everyone. In this class, I am going to discuss about EMF equation of a transformer. In last class, we are completing transformer working principle and operation. And from the operation of a transformer, we came to know EMFs induced in the primary and secondary winding of a transformer by by changing the flux linkages to the winding. Okay, means the EMF induced because of the change in flux is linking with both primary and secondary windings. Okay, therefore, to derive EMF equation of a transformer, to derive EMF equation of a transformer, I am considering flux as a reference. Okay, because same flux is linking with both primary and secondary winding. Same flux is linking with both primary and secondary winding. Therefore, to derive EMF equation, I am considering flux as a reference. Flux as a reference. This flux, we know that the flux produced in the transformer core is alternating. I am drawing alternating flux waveform. Alternating flux. This is omega t. This is 0. It is 5. It is 2 phi. And this is phi of t. Okay. And and this is the maximum value of positive flux. This is plus phi m, and this is negative phi m. Negative phi m. Since this flux is alternating in nature, therefore phi of t is equal to phi m sine omega t. Phi of t is equal to phi m sine omega t. You need to remember this equation. Phi of t is equal to phi m sine omega t. Okay. Next, let's phi is equal to flux in the core of the transformer, and phi m is nothing but maximum value of flux measured in Webers. Maximum value of flux measured in Webers, and F is nothing but supply frequency measured in hertz, and N1 is nothing but number of turns on primary. And the last class we are drawing the transformer diagram. In that, primary having N1 number of turns and secondary having N2 number of turns. N1 is equal to number of turns on primary, and E1 is the RMS value of the primary induced EMF. RMS value of primary induced voltage EMF, or we are calling this EMF is called as E1 is nothing but self-induced EMF. Self-induced EMF. The EMF induced in the primary we are calling as self-induced EMF. This self-induced EMF is in RMS form. Okay. Next, it is the RMS value of the secondary induced EMF. And this secondary induced EMF we are calling mutually induced EMF. Mutually induced EMF. I already explained what is meant by self-induced EMF and mutual induced EMF. And next, N2 is nothing but number of turns on primary, and B is nothing but maximum flux density in the core. B is nothing but maximum flux density in the core, measured in Webers per meter square, and A is nothing but cross-sectional area of the core, measured in meters. Yeah. Next, we know that according to Faraday's laws of electromagnetic induction, the EMF induced in a conductor, the EMF induced in a conductor is directly proportional to the rate of change of flux linkages in it. EMF induced in a conductor is directly proportional to rate of change of flux linkages in it. Therefore, the EMF induced in the primary winding We are calling it as E1 is directly proportional to d phi by dt. This is according to Faraday's laws of electromagnetic induction. D phi by dt. E1 is equal to E1 is directly proportional to d phi by dt. To remove proportionality constant, I am introducing the number of turns on primary. Number of turns on primary. From this, I am writing E1 is equal to minus N1 into d phi by dt. E1 is equal to minus N1 into d phi by dt. Suppose this is, I am assuming, equation number 1. Okay. And we know the equation of phi is equal to phi m sin omega t. Therefore, substitute the phi value in equation 1. Substitute the value of phi in equation 1. Substitute substitute the phi of t value in equation 1. In equation 1. Therefore, E1 is equal to minus N1 d by dt of phi m sin omega t. Phi m sin omega t. Therefore, and phi m is constant, take outside, minus N1 phi m d by dt of sin omega t. Okay, and differentiate sin omega t with respect to time. Okay, minus N1 phi m. What is the differentiation of sine? It is cos omega t. Again, differentiate omega t with respect to t, which is omega. That is equal to minus N1 omega phi m cos omega t. And our flux equation is in sine form. Then convert this cos into sine. I am writing minus N1 omega phi m sine of 90 minus omega t. Sine of 90 minus omega t. And minus N1 omega phi m. I am rewriting this equation minus sine of omega t minus 90 degrees. Just I am taking the minus sign common from this. Therefore, omega t and minus 90. When I'm multiplying with minus sign, minus omega t plus 90. Okay. And from this negative sign becomes positive. Negative into negative, it becomes positive. Therefore, N1 omega phi m sine of omega t minus 90 degrees. Sine of omega t minus 90 degrees. I am writing this N1 omega phi m. I am writing this by E1m. And it is E1m. Means it is the maximum value of self-induced EMF. Sine of omega t minus 90 degrees. Sine of omega t minus 90 degrees. This is the alternating voltage. This is the alternating voltage equation of induced EMF in the primary. And from this equation, observe clearly, and it is E1 max sine of omega t minus 90. And where phi is nothing but phi m sine omega t. By comparing these two equations, our induced EMF in the primary is lagging flux by 90 degrees because it is omega t minus 90. Because it is omega t minus 90. Therefore, E1 is lagging flux by 90 degrees. Okay, same flux is linking to secondary also. Therefore, E2 also is lagging flux by 90 degrees. Similarly, E2 is also lagging flux by 90 degrees because same flux is because of the same flux EMF induced in the primary and secondary. Is it clear? And where where E1M is equal to maximum value of self-induced EMF, maximum value of E1, otherwise maximum value of E1. And but we know that in AC the voltage and current are in RMS values. Voltage and current are in RMS values. Then find the RMS value of induced EMF. Find the RMS value of RMS value of primary induced EMF E1. Therefore, E1 RMS, we know that RMS value of voltage E1 max by root 2. E1 max by root 2. What is mean by E1 max? E1 max is nothing but N1 omega phi m. N1 omega phi m. Right? N1 omega phi m by root 2. And here N1 and phi m are constant. N1 and phi m are constant. We are writing omega is nothing but 2 phi f by root 2. Otherwise, N1 phi m f into 2 phi by root 2. 2 pi by root 2. From this, E1 RMS is equal to 4.44 F phi m N1. This is the EMF equation, induced EMF equation of a transformer. Induced EMF equation of a transformer. E1 RMS is equal to, is in volts. Okay. Similarly, similarly, the EMF induced in the secondary. Similarly, the EMF induced in the the secondary, that is E2. E2 is equal to E2 max sine of omega t minus 90 degrees. Okay, same here. E2 is lagging flux by 90 degrees. Same. Then E2 RMS is equal to 4.44 F 5M N2, where N2 is the number of turns in the secondary. Where N2 is the number of turns in the secondary. Where N2 is nothing but number of turns in the secondary poles. Is this clear? And this is the EMF equation of a transformer. Thank you. This rate of change of flux linkages in it. Rate of change of flux linkages in it.